So this is chapter 11, video reassessment. Alright, the question is: a spinning disk has a radius of 1.5 meters and an angular velocity of negative 2 radians per second. The moment of inertia of the disk is given at 300 kilograms meter squared. A 30 kilogram child runs at negative 5 meters per second and jumps on the disk, on the edge of the disk. What will be the new angular velocity of the disk with the child on it? Alright, so we're going to be looking for the angular velocity. Okay, so this is what's given in the problem right here, and I just drew a little picture, help out. So the disk is moving clockwise, so drop your pencil, do the right hand rule, and you're going to see that it's moving in a negative direction. So I mean, well, your answer is going to be negative because it's going down. Alright, so then that's why we have negative right here. But anyway, well, it's given in the problem too, but it's going to be negative. We know that. And we know that the final answer is going to be negative. So we're looking for the angular velocity once this person's on the disk. So the disk and the child are going to be in the system, and we're looking for the angular velocity after that happens. Alright, so we're going to start off with angular momentum initial equals angular momentum final, and then we have so what's going to be in the initial, what's going to be in our system is going to be the disk and the child. So we're going to have the initials of both equals final disk plus child, and we have only one term here because once the child jumps on the disk, that's going to be one thing. So it's going to be angular momentum final is disk plus child, and they're not separated. All right, so then we got so then we just break it down further. Moment of inertial angular velocity of the disk plus moment of inertia plus angular velocity of the child was times, but equals. And then we got the same thing as we did in chapter 10. We can, since they're together, we can pull out the angular velocity. So we pull out the WF, which is what we're looking for. This is what we're looking for. This is the final angular velocity. So we can pull it out of this. So yeah, this one has it in there. All we do is just pull it out because it's going to be the same for both of these. Alright, so then we just going to simplify the equation. So divide that over here. So then we end up with the final angular velocity equals our equation. Alright, and then we got to find each term in the equation. So then we have, this is given in the problem. This is the moment of inertia of the disk. This is given in the problem, and this is also given in the problem. This is the angular velocity of the disk is moving negative 2 radians per second. And then we have the moment of inertia of the child equals mass times radius squared, because the child's on the edge of the disk. And then so all we gotta do is plug in our mass, 30 kilograms times 1.5 meters per second squared. This is kind of tricky because well, no, not this, but this is equal 67.5 kilograms meter squared. But this is kind of tricky because we gotta find the angular velocity of the child, and you know, some people get this confused because the child's running in a straight line. I mean, some people are like, how does he have angular velocity? He's running in linear. So then we use this little formula right here. This is velocity transitional. I don't know, I can't say it, but anyway, the velocity of the child running the linear motion. This is what velocity t is. It's the child running the linear motion equals the radius times angular velocity. So then we have two of these terms. We have the radius of the disk and we have this velocity. So then we just move the equation around to find the angular velocity, and then we end up with velocity over radius, and then we do it right here. Velocity over radius equals 3.3 radians over seconds. Alright, and then we get a final angular velocity, same thing we have here, except we plugged in all our values and we solved, and we end up with angular velocity is equal to negative 1.02 radians over seconds, and we're sure our sign's correct because of the right hand rule, because it's moving clockwise, so we turn around and our thumbs down. And that's it.